In this lesson, we're going to switch gears from the last two videos where we focused on graphing first exponential functions and then into logarithmic functions. Now we're going to transition into solving some equations, and this is solely going to be exponential functions, all right? And the goal of this is to write each side with a common base, okay? So let's start with this first one here. We have 5 to the power of x, so 5 to the power of x equals 1 over 125. Well, I know that 5 cubed is 125, but it's not equals 125, it's equals 1 over 125. So what I'm going to do is I'm going to rewrite that as 5 to the negative third power. And when you have the same base, you can actually set the exponents equal to each other. So x is going to be equal to negative 3. All right, that's kind of the goal of this, is try to rewrite them with the same base, if possible. Okay, let's try B. B, I'm going to leave this one alone. 3 to the power of x plus 1 equals, rewriting 9, I'm going to write that as 3 squared. Now, there's already an original exponent here of x minus 3, so I'm going to copy down that x minus 3. If you remember from your days in Algebra 1, we have a power raised to another power. We're going to multiply those. So the left side still comes down, but this new exponent becomes that 2 times each of those values in the other exponent. So 2x minus 6. Now the bases are the same, so I can set x plus 1 equal to 2x minus 6. Now when you get to this step, you'll notice this is no longer an exponential equation. This is a linear equation. So just get your x's to one side, everything else to the other to solve for it. So we have 2x, I'm going to leave there. I'm going to move this x over with subtraction to get 1x. Move the minus 6 over with addition to get 1 plus 6, which is 7. So that is it for letter B. Let's try C. All right. Now, in this one here, I have x to the 2/3 power equals 25. All right. So the way we want to do this is there a way that we could get that power out of that exponent? Okay. And how we're going to do this is we're going to introduce the logarithm. So essentially, if I'm unable to rewrite these two equations with the same base, or I should say two sides of the equation, then I'm going to introduce the logarithm to allow me to move that exponent out of the power. All right. So for this one, actually, I don't need to do that because my exponent doesn't have the variable. But what I'm going to do is I'm going to copy it down. And then I want to get rid of that 2/3 power by raising it to the reciprocal of the 3/2 power. Do the same thing to this side. All right. Just like we did before, when you have a power raised to a power, they multiply. 2/3 times 3/2 is just 1. And then on this side, I'm going to rewrite that as 25, but draw a radical symbol. My denominator is the index, which I don't need to write since it's 2. And my numerator, I'm going to cube it when I'm done. So I get x equals, the square root of 25 is 5. But now I need to cube it. So x equals 120. All right? This is a little bit different because I didn't have to write each side with the same base, but it allowed me to use my understanding of rational exponents like we did in our previous unit. Okay, let's try this last one. So I have 16 to the x minus 2 power equals 9 to the 1 minus x power. Now, the tricky part about this is that we are unable to rewrite each of these with the same base. I can rewrite 16 as 2 to the 4th power, or I can write it as 4 squared, and I can rewrite 9 as 3 squared, but I can't write them with the same number. So this is where I'm going to introduce the log of both sides. So I'm going to write the log of 16 to the x minus 2 power equals the log of 9 to the 1 minus x power. All right. Now, by doing this, this allows me to take these exponents and move them to the front of the logarithmic equation. So I'm going to write x minus 2 times the log of 16 equals 1 minus x times the log of 9. Now, because I have expressions that are not just x by itself, I have x minus 2 and then 1 minus x, I am going to distribute that log times each of those terms. So I'm going to write x times the log of 16 minus 2 times the log of 16 equals the log of 9, right? 1 times the log of 9 is the log of 9, minus x times the log of 9. Now, when you get to this part of the equation, right, you'll see you kind of have 4 things. 2 of those have the variable x, and the other 2 just have numbers, right? So they are just numbers. I don't know what the log of 9 is at the top of my head, but it's just a number, right? So I'm going to move the stuff that has the variables to one side, the stuff that doesn't have the x to the other side. So keep the x log of 16 here. I'm going to write plus x log of 9, since I moved that from the right side. Leave the log of 9 on that side, and then write plus 2 times the log of 16, since I moved that over from the left side. All right, now you'll notice that my 2 expressions on the left side have an x in common. So I'm going to factor out an x to get the log of 16 plus the log of 9 equals the log of 9 plus 2 times the log of 16. So to get x by itself, I'm going to write x equals, and to move this log of 16 plus log of 9 over, I'm going to use division. So it's the log of 9 plus 2 log of 16 all over the log of 16 plus the log of 9. All right, now that's a lot, right? I'll just be honest with you. That's the most challenging part of this video, is recognizing you can't rewrite the bases on each side with the same number. So you have to introduce the logarithm to move the exponents to the front of those logs. And then this is the most complicated because I have those instances where the expression from the exponents are not just a variable, it's got a number with it. So you'll have to distribute, get the stuff with the variables to one side so you can factor it out. All right, so that is it for D. That's it for this video. I know it's a short one, but check out the practice questions and then come see me, especially if you have any issues with these more challenging ones. All right, good luck.